Welcome to this explainer. Today we're taking a truly fascinating journey down a path we literally use every single day, yet almost never really think about. We are exploring the upper gastrointestinal tract. So get ready, because we're going to track the exact journey of a single bite of food, uncovering the incredible mechanical and chemical processes that keep us alive and fueled.
I mean, really think about this for a second. What actually happens the moment food leaves your tongue? We completely take chewing and swallowing for granted, right? But the second we commit to a bite of food, this wildly complex, entirely subconscious series of mechanics just fires up. It's this highly coordinated, perfectly timed operation that turns a solid piece of food into cellular fuel.
Okay, let's dive into this. Here's our roadmap for digestion today. We'll start at the mouth, move on to deglutition, travel down the esophagus, head into the stomach, and wrap things up with a few clinical detours. Station 1, the mouth, mastication and saliva. Now, you might think digestion happens mostly in your belly, right? But as your teeth mechanically crush your food, your glands immediately start pumping out fluid. And surprisingly, that fluid is 99.5% water. The remaining 0.5%, that contains some absolutely crucial solids. This hypotonic fluid perfectly moistens and dissolves the food. Without it, rolling that dry, chewed-up food into a smooth little ball or bolus that can safely slide down your throat would be practically impossible. But your mouth isn't just a mechanical grinder. It's actually a high-speed chemical laboratory. Enzymes immediately start dismantling your meal. Salivary amylase attacks cooked starches, converting them into maltose. Then, maltase is present in trace amounts to push that maltose right into glucose. Meanwhile, lingual lipase, which is secreted from the back of your tongue, gets right to work hydrolyzing milk fats. The chemical breakdown literally starts the second the food hits your mouth.
Which brings us to phase 2, deglutition, the swallowing reflex.
Deglutition is broken down into 3 distinct, highly choreographed stages. Stage 1 is the oral stage, and this one's completely voluntary. You decide exactly when to push that food backward with your tongue. But the moment that bolus enters the pharynx, everything changes. Stage 2, the pharyngeal stage, and Stage 3, the esophageal stage, are entirely involuntary reflexes controlled by your brainstem. You're no longer driving the bus here, your autonomic nervous system just takes over completely. In a fraction of a second, your anatomy dynamically reconfigures itself to protect your airways. You see, the pharynx is a shared pathway for both air and food. So, to prevent you from accidentally inhaling your lunch, the soft palate elevates to completely block the nasal cavity above, while the larynx moves upward and the epiglottis swings backward to seal off your vocal cords and trachea below. The food is given literally no other choice but to enter the esophagus. And this incredible physiological safety mechanism leads to a phenomenon known as deglutition apnea. Think about this. Every single time you swallow, your nervous system temporarily, completely halts your breathing for a few seconds. This deglutition apnea ensures that absolutely no airflow draws food particles into your respiratory tract. It's an automated built-in failsafe that we trigger hundreds of times a day without even noticing. Which is a good thing, because if we had to remember to do it manually, just eating a sandwich would be exhausting. Moving on to Station 3, the esophagus, moving the bolus. So the esophagus is definitely not just a gravity pipe. It actively pushes the food down. When the bolus enters, it triggers primary peristaltic contractions. This is a powerful, sweeping wave of muscle constriction that generates positive pressure to literally force the food downward. But what happens if you swallow a piece of dry bread and it kind of gets stuck? Well, that's where secondary peristaltic contractions come in. Triggered by the actual physical stretching of the esophagus wall, these secondary waves act as your body's automated backup plan, making sure that stubborn bolus makes it all the way to the stomach.
And that brings us to step 4, the stomach, acidic digestion.
Just look at the sheer volume of production happening here, 1.5 liters. That is the maximum amount of gastric juice your stomach can produce in a single day. The walls of your stomach are lined with gastric glands that tirelessly pump out this immense volume of fluid to make absolutely sure whatever you just ate is aggressively broken down. And the fluid filling that space? Yeah, it isn't just water. The pH of your gastric juice sits between a staggering 0.9 and 1.2. To put that into perspective for a second, battery acid has a pH of around 0. Specialized parietal cells secrete highly concentrated hydrochloric acid,
It's so caustic that it instantly kills almost any bacteria entering along with your food, acting as a super potent immune defense, and it provides the exact acidic trigger needed to activate the stomach's heavy-duty digestive enzymes.
Those enzymes are specifically engineered to thrive in this intense acid bath. Pepsin, which is activated directly by that hydrochloric acid, just ruthlessly attacks complex proteins. Gastric lipase targets butterfats, gelatinase goes right to work degrading heavy meat collagen, and urase tackles urea. The stomach isn't just gently mixing your food, it's conducting a profound, aggressive chemical disassembly.
All of this intense mechanical churning and chemical degradation yields one very specific final product: chyme. This is the ultimate result of the stomach's hard work. It's an acidic, semi-solid mass that barely even resembles the bite of food you took a few hours ago. This chyme is now perfectly prepped to be slowly, carefully emptied into the small intestines for nutrient absorption.
Finally, Part 5, Clinical Detours, when digestion goes wrong.
So, the crucial point here is that mapping out the normal physiology gives us the exact blueprint we need to understand what happens when things break down. For instance, at the junction of the esophagus and the stomach sits a crucial muscular door called the lower esophageal sphincter, and we can see two very clear mechanical failures here. In esophageal achalasia, the sphincter fails to relax when food arrives. Basically, it's a locked door, causing food to painfully accumulate in the chest. Contrast that with GERD, where the sphincter is incompetent and fails to constrict. The door won't shut, allowing that extremely caustic 0.9 pH stomach acid to just splash back up into the unprotected esophagus, causing severe heartburn.
We also see what happens when the stomach's chemical balance gets thrown completely off. Peptic ulcers occur when the protective mucus barrier drops, or the extreme hyperacidity begins to literally digest the stomach's own walls. Real-world triggers for this include chronic use of NSAID painkillers like ibuprofen or an infection from Helicobacter pylori bacteria. In really extreme cases, like Zollinger-Ellison syndrome, a tumor elsewhere in the body causes this massive, uncontrolled overproduction of hydrochloric acid, completely flooding the system.
Which leads us to a final thought to take away from this explainer today. Given the perfectly coordinated mechanical waves sweeping down your esophagus, the intensely lethal chemical acid baths in your stomach, and the split-second, life-saving airway closures in your throat, how absolutely incredible is it that you just digested your last meal without even thinking about it? The human body is a spectacular piece of automated engineering. Next time you take a bite, take a moment to appreciate the incredible journey it's about to go on.